The first thing you might have noticed when installing v-ray 2.0 was that there was an option to register v-ray menus, and what this option does is it adds the v-ray objects to the create menu in 3ds Max. So now you can create the proxies for a v-ray plane or a v-ray sphere directly from the create menu. You also have the v-ray lights available here, and of course the v-ray cameras, and you can also create a v-ray light meter from the helpers submenu. Some of the biggest changes in v-ray 2.0 are in the v-ray frame buffer, and one of the first things you'll notice is there's a new button here for showing the history. This was available earlier in v-ray through system variable hack, but the feature was considered to be unstable and in beta, so people could enable it at their own risk. This is now considered a stable feature, and it's really nice because it allows you to store your render history on disk. All the images are saved as VR image files, and by using the options button you can decide where on your hard drive the pictures are stored and the maximum amount of space you're allowed to use for the history. If you use more than, for instance, 100 megabytes, the oldest picture will be deleted. And since these are stored as v-ray image files, you also get all the render elements and everything included in every file, and you can go back and check those later. Now, a really nice feature with the render history is these new buttons, the AB, compare horizontal, compare vertical buttons. So I can take an old rendering and I can set this to A, and I can take my recent rendering, set this to B, and I get a vertical divider through my image, allowing me to scrub back and forth and checking differences. I can load different images into each channel. Like here I have just slight variations in the glass material, and it's really helpful for checking changes in an image after you change the setting. You can use the swap AB button here to reverse which side the A and B image is on, like this. And you can also have a vertical line. If you want to remove an image from your history, you can just click it and remove it. So when you've rendered an image, the way to add it to your history, because they're not added automatically, you wouldn't want to fill up your render history with test renders that you didn't want there. So the way to do this is to just use save, and it will save the latest image into the render history. And to clear it out completely, use clear. Another addition to the v-ray frame buffer that you'll notice is that you now have a render last button in the v-ray frame buffer directly, and this is just really useful because you don't have to go back to the Max interface. If this is hidden behind some windows or something, you can just start a new render directly from the v-ray frame buffer. A last addition to the frame buffer is you can now use numerical input for the color curve correction. So I've selected this point down here, and at 0 I want this to have a value of 0.1. So I can just enter this in numerically, and you don't have to, fiddle about with this trying to align it perfectly. You can just go in and just type it in directly. Finally, there's some small changes here in the v-ray image file and the split render channels area of the v-ray frame buffer rollout. The first thing you'll notice is that when you browse now to save the v-ray image file, you now have an option to select OpenEXR as the format. Previously in 1.5 you could just change the file extension and it would save it as OpenEXR, but this was sort of a secret feature that a lot of people didn't know about, and another disadvantage of this was that it would always save the image as a 32-bit EXR. For a lot of uses, you don't need to use more than 16-bit half float in OpenEXR, so you can now turn off use 32-bit output and it will save the images as 16-bit half float EXRs instead. And the last change here in the split render channels is that often if you had really long file paths, you wouldn't actually see what file name you were saving out as. This is now shortened so that you'll always see the file name at the end here. And also when you browse to type in a new file name, it actually now remembers your file name. Previously in 1.5 you'd just get a blank text field here. So these are some of the changes that are important in v-ray 2.0 and that add a lot of productivity to working with the frame buffer, working with images, and also managing saving images. For this section I'll be talking about the new dispersion effect in the v-ray material in v-ray 2.0. Previously in v-ray 1.5 you could use a v-ray blend material to create something that looked like dispersion. Basically you'd have 3 different glass materials or refractive materials in the coat material slots, and then you'd vary the IOR slightly between these materials. Then by filtering using red, green and blue, these 3 materials would then be blended back to create your final result. This would be a pretty good approximation of the dispersion effect, but you wouldn't really get the exact same spectrum effect that you would with the correct dispersion effect. And also it could be very slow to work with because first of all you'd have to go into each individual coat material and adjust the index of refraction individually just to adjust the amount of dispersion effect. And then also to prevent banding you'd often want to introduce some blurriness to the refraction, and this would really make the render time skyrocket. So it's really not very efficient, and v-ray 2.0 has a much better way of doing it. So let's take a look at it with this scene I've set up. It's a glass sphere, I have a glass animal figurine, and I have a diamond object. And let's just render this first without any dispersion turned on, just so we have something to compare with. Okay, so the image has rendered, and this is basically what you get from a plain glass material in v-ray 1.5. If you look at the glass sphere here, and if we compare this to a photo of a real glass sphere, you'll notice that this has a really pronounced dispersion effect around some of the refracted highlights, and also dispersion effects which are just very subtle, but they're still visible in other areas of the glass sphere. So if we go back to Max, I'll just save this to my render history so that we have something to compare with, and I'll open the material editor and the glass material I've used for these two objects. This is just a basic glass material, white reflection, white refraction. The IOR is 1.56 and I have Fresnel reflections set up. This is what you'd basically start with most glass materials in 1.5. Now in 2.0 we have the new dispersion effect, and I'll enable this by clicking the checkbox, and the amount of dispersion is controlled by the Abbe parameter. The Abbe parameter is named after this guy, Ernst Abbe, who was a scientist, German scientist for Carl Zeiss. He was actually a co-owner of Carl Zeiss, and he came up with something called the Abbe number, which is a measure of any transparent material's variation of refractive index with wavelength. Basically what this means is that v-ray, by using the Abbe number and the index of refraction, will be able to correctly calculate the dispersion of the material. So let's just render this image now with the dispersion enabled. And the irradiance map looks really colorful, but the final rendering won't have the same artifact. I'll pause the rendering, I'll pause the recording while rendering, so we save some time. Okay, so now the rendering finished, and I'll just save this as well. Now if you look at the refraction, especially in this animal figurine, but it's also visible along some of the refractions in the sphere, you'll notice you have a much higher degree of realism in the refractions here. It's something that we pick up really subtly, but it really adds a lot to the realism of your renderings. Let me just load the original rendering into channel A and then the new rendering into channel B. We can see the big difference, like this really bright refraction here. This is very dull and dead and sterile, while this one has much more life. Okay, so let's add dispersion to the diamond as well. I'll go into the diamond material, and this is basically the same as the glass material, except I have set the IOR to something that most people know is the diamond IOR. It's 2.41. I'll enable the dispersion, and this comes up with the default value of 50. Now how do you figure out what Abbe number to use to produce a physically correct result? Well, there's a really great resource online called refractiveindex.info, and it's a big database of different materials, and it has their refractive index. So I can go and select crystals, and I select carbon, diamond, and I get the index of refraction. It's actually 2.3871, and the ABA number is 55.3 and 54.86. So what I like to do is I usually take the average of these two, so let's use 55 just as an approximation. I'll go back to max. I'll put 55 in here, and I'll put 2.38 in here since that was the value that refractive index info told me to use. Okay, so let's render this. And I'll pause this again. Okay, so the image finished rendering, and I'll save this. I'll load the previous rendering into A and the new rendering into B, and now you can really see how the dispersion brings this diamond to life. There's dull piece of glass and a real diamond. Of course, sometimes you want to exaggerate the effect even more, and the way to do that is to lower the ABI number. Lower values produces a lot more dispersion, and higher values produces less dispersion. So just to try it out, let's set this to 10, and then let's also set the glass to 4. And let's re-render this. I'll pause the rendering again, or the recording actually. So the image is finished rendering, and I'll just save this as well. I'll load the previous into A and the new one into B, and you can see how lowering the ABI number really exaggerates the effect, or just makes it a lot stronger. So depending on what you need, sometimes the physically correct value isn't really the image you're after, so you can use the artistic license and exaggerate the dispersion effects when you need it. And if you look at the render times over here, you see without dispersion it renders fairly quickly, and actually I'm using adaptive subdivision for this, so it really adds a lot to the render time when you enable dispersion, but varying the amount of dispersion between A and B here doesn't really add that much render time. Dispersion also supports caustics, so next we'll be looking at a scene with caustics. So let's look at how dispersion works with caustics. In this scene I have a very simple glass prism that rotates slightly, And to the left of this, I've set up a v-ray planar light with the directional parameters set to 1, so that it acts sort of like a slit light with one parallel beam of light moving this way through the scene. The material of the prism is about the same as the glass material in the previous part of this section. I've set the Abbey parameter to 4 just to produce a really exaggerated caustics dispersion effect. I've enabled caustics, set my search distance to 0.1 centimeters, and just increased the max photons number slightly. So let's try to render this and see what it looks like. First I'll just render it with the prism outside the beam of light. I'll just move to a different frame and re-render this. You'll see it calculates the caustics photon map. And you can see how this produces a really nice rainbow spectrum, a really correct dispersion spectrum based on how the light is refracted differently inside the prism. I have an animation of this as well. You can see how the dispersion varies when the angle that the light hits the prism with varies. Like right here you see the blue rays here, they hit at a slightly different angle, so they get reflected back out there and they collect. So the blue part of the spectrum is, because it's reflected twice, it isn't dispersed as much and it gathers into this parallel beam, which is physically correct. And then more and more of the colors of the spectrum are get part of this new caustics beam. So let's go back to max and look at one more thing in the dispersion. Dispersion also supports fog now. So I've added a bright red fog color. So if I render this, you'll see that the wavelengths based on this color, it only lets through the red light. All the other colors are absorbed in the glass material, so it only lets the red light through. If you add like a blue component to the color and you re-render, you'll see that you get that part of the blue spectrum as well, but because of this color doesn't really have any green in it at all the green colors in the middle of the spectrum are absorbed. So you can play with the fog color to create some really interesting caustics dispersion effects. Okay, so this concludes the dispersion part of the v-ray 2.0 new features training videos. In this section I'll be talking about the new dim distance feature of the v-ray material in v-ray 2.0. In this scene I have a simple white horse object and a reflective floor. I'll just render this real quick so you'll see what it looks like. Okay, so the floor is perfectly reflective. And I'll open the material editor and show you the material of the floor. It's got white reflection and no Fresnel or anything, so it's just a perfect mirror. Now in v-ray 2.0 you have this new parameter, or this new effect called dim distance. So I'll enable this and render again. What you can see now is that v-ray stops tracing reflections for this material after 400 scene units, and this can be a really good way to speed up rendering. If you, for instance, have a lot of reflections, you can make v-ray stop tracing the reflections, saving a lot of rays. The dim distance parameter, if you adjust this to a smaller number, you'll see that the reflection stops much faster, and then you can extend it and you get more reflections. Of course, this really hard edge isn't what you want most of the time, so there's a fall off parameter for the dim distance effect. And the way this works is at 0 you just get a hard clip on the reflection, and if you set it to 1 and render, the reflection is dimmed out over the entire distance. And then you can play with this parameter to adjust the amount of fall off, so you can have a strong reflection up to a certain point, like in this case up to about halfway, 190 units approximately, and then the fall off starts happening in the last 180 or 190 units of the reflection. Now this can be a really good speed up, especially if you have less than perfect glossiness in your reflections, because if you disable this and render, v-ray needs to spend a lot of time on the very blurry reflection down here, but sometimes you don't really want this as part of your image, especially if you have something like Fresnel enabled. Where they don't really contribute that much to the final image, and it's a good way to just enable the dim distance parameter, and you see the render time went from 10 seconds and down to 6 seconds. So this can be a really big time saver and a way to speed up scenes that have a lot of especially unsharp reflections. In v-ray 2.0 there's a new v-ray car paint material, and to show how this works I've set up a very simple scene with just a square and a sphere and a couple of v-ray lights, and also I'll be rendering this with v-ray-RT just to get interactive feedback. So let's open the material editor and assign a v-ray car paint material to our objects. And this comes in with the default settings, and you can see the flakes and the gloss layer and the base layer. Now the v-ray car paint material has 4 layers actually. There are 2 layers in the base layers. There's a diffuse layer and a reflection layer, and the color of both of these layers is controlled by the base color. The base reflection controls the strength of the base reflection of the base coat, and the base glossiness controls the sharpness of the reflection. So we can go in and vary the change the color to like a dark red, for instance, slightly purple maybe. And then you can increase the strength of the reflection of the base coat, make it sharper, just to create the kind of look that you want. So for now we'll just put this back down. Now the flake layers has a lot of controls. First of all, there's the flake color, which is the reflection color of the metallic flakes in the car paint. The flake glossiness determines the glossiness of the reflection of the flakes, and basically this means that if the glossiness value is lower, they'll pick up more reflections from their surroundings, but the reflections won't be as bright as if this value is higher. So if I decrease this, you'll see they start picking up more reflections further away from the light sources, but also the reflections of the flakes aren't as bright. I wouldn't recommend setting this to anything above 0.9 though, because if you set it to 0.1 you start getting artifacts. If you set it to 1 you get artifacts. So usually the default value of 0.8 is pretty good, but of course you can play with this to get the exact look that you want. Now the flake orientation determines how much the normal of each flake varies compared to the surface of the object that the flakes are on. So if I set this to 0, all the flakes will also have the same normal as the surface, and you can see you only pick up reflections or highlights in the exact same place as on the rest of the object, and by varying the normals here more, you start to pick up those little glints of the flakes further away from where the rest of the car paint picks up reflections, and this is what gives metallic car paints that sparkle effect that you know of. Again, increasing this to more than 0.5 usually doesn't really give very good results, because the normals will start deviating too much away from the surface and give you this unnatural look where the flakes don't really correspond to the other reflections anymore, and it doesn't come across as a believable car paint material. So usually a value of 0.3 to 0.5 is good here. Now flake density controls how many flakes there are in the flake map that's generated by the v-ray car paint material. And by increasing this, let's set it to 2. Now you'll see we get a lot more flakes here. So depending on the look you're after, you want to play with the flake density parameter just to get enough flakes in your car paint. Now flake scale, this actually controls the scale of the entire flake structure. So if I double this from 0.01 to 0.02, you'll see that the spacing between each flake doubled, and also each flake is now twice as big. And this is a good parameter for controlling the overall look on your object. Depending on which mapping type you use, you want to use very different values here, depending on your UV coordinates, or if you use the other mapping types that I'll be covering in just a few minutes. I'll set this back to 0.01. And flake size controls the size of the individual flakes without changing the flake position or the scale of the structure. So I can go in and set this to 1, and I get flakes that are twice as big as the ones I originally had. Or I can set it to 0.25 to get smaller flakes. Now, the flake seed is just a random seed for generating the map, and this is a good thing if you want to just vary the flake seed between different objects. If you're getting the same pattern in two different objects, for instance, and you want to vary it, you can just type in a different number here to generate a different flake pattern. The v-ray car paint material has two different types of flake filtering. There's one called directional, which is a default, and there's also a simple filtering. Simple filtering uses a lot less memory, so it might be good in some situations, but the results that it produces isn't as accurate as the directional filtering. So for final renderings you should use the directional filtering. A very important parameter is the flake map size, because the v-ray car paint material generates this flake map internally. You need to make sure that you have enough resolution in the map to cover your object. If the resolution isn't high enough, you will get visible tiling in the flake structure, and I'll show this by setting the flake size down to something really small, like 64. And you'll see here that you get very visible repetition of the flake structure. So make sure that your flake map size is set high enough not to get visible tiling. Now, the flake mapping type is another important parameter. The UV mapping of your objects is really important, and I can show this by adding a UV map to this plane. And I'll just rotate. You'll see that this actually stretches the flakes. So it's very important that you have good UV coordinates in your map in order for it to be believable. And you can also sometimes see this problem, for instance, on the sphere here. If we increase the flake size, you'll see that because of the mapping coordinates of the sphere, you'll get smaller stretched flakes towards the top here, and they'll be bigger the further down you get on the sphere, and this doesn't really produce a very believable result. So if you don't want to set up the UV mapping for your object, or if it's an object that's hard to UV map correctly, you can use something called triplanar from object XYZ, and that way the V-ray car paint material will figure out the best mapping for your object, and this works really well on things like spheres and on most car objects as well. And you might have noticed one thing is that once I changed the mapping, the whole flake scale structure changed drastically, and you need to go, when you change the mapping type, you usually need to go and change the flake scale. So I'll increase it a lot to get back to the result we had. Of course, I'm working with very enlarged flakes now, just to be able to show the different parameter changes. I'll reduce this to something less brutal. Let's move on to the coat layer. This is the top coat that goes above the flakes, which is usually a clear coat, but you can also change the reflection color here if you want to. You can introduce a color into the top coat to tint that. The coat strength determines how visible the reflection from the coat layer is at points facing the camera. So if I increase this, my coat layer becomes more like a mirror coat. So typically the default value is pretty good here. And you can also introduce some blurriness to the coat layer as well. Because most car paints don't have a really perfectly polished top coat, so some blurriness in the reflection is good for added realism here as well. So in the options here, you can choose whether you want to trace reflections. You can just disable the reflections completely. You can make the material double-sided. You can increase the subdivs and the cutoff threshold. A really interesting feature is that you can add maps instead of the color swatches for all the different values here. For instance, if you want to create a candy paint look, you can add a fall-off map. Now the fall-off map will let you vary the colors based on surface normals in relation to the camera. So I'll just set the front to a really bright red color, and then the side I'll just put a darker, almost purple color. And this is a good way to get that really nice candy paint look that you see on a lot of like hot rods and those type of cars. And you can also add some bump to the coat layer, which is good, as most production cars, for instance, don't really have a very perfectly smooth coat layer. If you look really closely, you'll see that there's tiny bumps all over the coat layer. So if you want to have shots where you get really close to your car, you'd want to add some slight bump as well. And then you can just decrease the amount. Just introduce a small variation in the top coat reflection. From far away, you wouldn't want to see this, but once you get really close, this is something that will add a lot of realism to your car rendering. Okay, so let's take a look at this shader on a more real-world scene. Here I have a scene with a Ford Mustang, and I've set up a very basic car paint shader on the car. As you can see, I've set the flake density to 0. So right now, this is just the base coat and the top coat, like a plain non-metallic car paint. And this is something you need in many cases as well, so it's good to be able to turn the flakes completely off. So let me just find a good angle here for showing the bump effect in the top coat. Right now there's no bump effect in the top coat, but I've added a noise map to the material in the bump slot, and this is just a noise map with a size that corresponds to my scene scale. And by enabling this, you'll see that in the high contrast areas of the reflection, it's going to start picking up some minute bumping, like around here. It's very visible, and you'll also see it up here on the hood. And this is something that will, like I said earlier, add a lot of realism to close-up renderings. So now let's modify this car paint material into something more interesting or colorful. So I've added a fall-off map with a Fresnel fall-off to the base coat, and I'll enable this. So now we get the slight color variations from the glancing angles and when we see it head on. And then to make this even more interesting, we can go in and turn the flakes back on. And then we can set a flake color that's better for the look we want. And maybe even scale the flakes up a tiny bit. You can see the flakes here in the car paint are picking up some reflections from other areas of the HDRI that is lighting this scene. and it adds a little bit of extra sparkle to the paint, especially if I zoom in around this area. And this car is mapped with a triplanar from object XYZ method because that saved me the time of having to UV unwrap the whole car model. You can see from this angle that the car paint really picks up a nice shine from the environment due to the flakes. Of course, the v-ray car paint material isn't just restricted to car use, so in the next part I'll be showing you how to use the flake component of the v-ray car paint material for other effects. So here I have a completely different type of scene where I'm actually using the v-ray car paint material, or the flakes component of the v-ray car paint material, to add some sparkles to the snow material of the igloo. And the way this is set up is I have a v-ray blend material on the igloo, and the base material is v-ray fast subsurface scattering 2 material with cool colors to produce a snow look. And then on top of that, in additive mode, I've added a v-ray car paint material, and what I've done here is I've set the base layer color and the coat layer color to black so that they won't be part of the additive calculation, and then flakes are set to almost white, and that way only the flakes will be part of the final blend material. So let's render this and see what it looks like. I'll pause the recording during rendering. And as you can see, the v-ray car paint material works really well for adding that small extra sparkle to other kinds of materials, so it's not just restricted to cars. Anywhere you need to use sparkles or flake-like structures, you can put the v-ray car paint material in a blend material and add these sort of details. It can be used for snow and ice, and even certain makeup effects on characters if you need that. So this concludes the v-ray car paint material section of these videos. For this section we'll be taking a look at the v-ray distance texture. This is a very powerful new addition to v-ray, and this texture is kind of similar to the dirt texture, the v-ray dirt texture, but the difference is that this texture is calculated before rendering takes place, and the advantage of this is that it lets you control various things in your scene through this texture. You can control things such as fur length or displacement or even particle emission using this texture. So let's take a look at this scene. I have a simple plane and a sphere, and I'll open my material editor and I'll add, just to show how the v-ray distance texture works, I'll add a v-ray distance texture to my plane, and then what I need to do is I need to go in and add the sphere to this texture. So let's just render this real quick and see what it looks like. As you can see, we now have a smooth fall off from the edge of the sphere, and which goes from black, which is a near color, to white, which is the far color, and the distance is 10 centimeters. So if you want a longer fall off, you can just change this. I'll set this to 25 centimeters and re-render it, and you see how the fall off changes. Of course, you can use this as a texturing tool if you want to create shadowed areas around things, or even rings around, like eyes on cartoon characters. It would be very easy to create with this texture. I'll go ahead and hide the sphere, or actually make it unrenderable so you can see what's going on inside as well. And this is the rendering when the sphere is hidden. You can see the texture measures the distance from the faces and doesn't actually treat the object as a volume, so it goes back to the far color out here. I can change the inside color to something different, and you can see how that affects the rendering. It goes from a black to a red. Another thing you can do with the distance texture, I'll set this back to black, is to put it inside an output map. I'll keep it as a submap, and then I'll enable the color map, and this allows me to change this gradient from a linear gradient to whatever I want. I can set this to a Bezier corner, and if I want more black with a sharper fall off towards white, I can do it this way. Or if I wanted to go really quickly to white, I can vary it this way. And this is really good when you're using this for things like displacement or fur length or grass length or anything like that, because it allows you to go ahead and create just the look you want. You can go in and add multiple points and create just the kind of outline you want. Like if you have ripples in water around an object, you can actually animate these curves. And the beauty of this is that if I go into the distance texture and I move my object, you can see that the distance texture updates in real time before any rendering takes place. So that's the basics of the v-ray distance texture, and next we'll look at how we can use this to control displacement and v-ray fur. Now we'll be looking at how we can use the v-ray distance texture to control displacement. So in this scene I have a plane with 40 by 40 segments and 3 objects on top of the plane. So let's start by just adding a displacement modifier to this plane. I'll set the strength to 10 centimeters. I'll just use the existing mapping, and I'll add a v-ray distance texture to the plane mapping slot. And I'll open my material editor and I'll instance this map in here, and now I have to go in and add the 3 objects that I want to control the amount of displacement. So I'll add the sphere, the horse, and the teapot. And you can already see that the map is updating in real time. And if you move things around, actually move the objects around, you'll see the map is calculated on the fly. And this is a really good way to create the effect of things being stuck in snow, for instance, without having to go in and model all the details and then remodeling the details whenever you move an object slightly. Of course, you can now go in and change the distance itself, and then you can also put this into an output map, keep it as a submap, and you can start playing with the curves here to get a better looking fall off, depending on what you want. You can even make it so that the displacement is less at white, but then you can pull it back up so you get mounds of snow around the objects. Now if you want to render this, you'll notice that well, because of the low resolution of the plane, you do get visible artifacts. And what I like to do is use the v-ray displacement for rendering, and then just use the displacement modifier in the viewport. So I'll go ahead and set that up as well. I'll select the plane and I'll set this to off in renderer, so that means if I render now, no displacement is going on at all. And then I'll just add a v-ray displacement modifier. And I'll pull my map in here, instance this, and set this to 10 centimeters, which was the amount we had in the original. So now if we re-render, v-ray uses displacement to displace the surface instead of the crudely displaced mesh. And you can get really precise and good looking curves and fall-offs and whatever you like. You can go in and maybe add a sharper edge like this. Re-render. You see how this changes the entire look of the displacement. You might want to subdivide the plane a bit more to get rid of these, or even out the curves. Like this one, you might want to even this out slightly. And I'll also add a bit more segments to the plane and re-render. See, now you get a much smoother but still sharp edge. So next we'll be looking at how we can control v-ray-fur using the v-ray distance texture. So now let's look at how we can control v-ray-fur with the v-ray distance texture. I have almost the same scene as in the previous sample, and what I want to do is I want to grow some grass on this plane, and I want the grass to be dense around the objects, and the density I want it to decrease further away from the objects, and I also want the grass to be shorter away from the objects. So let's set this up. First I'll go create v-ray-fur on the plane, and I'll set up the density, and I'll go into the density map here, and I'll assign a v-ray distance texture. Now I'll open up my material editor, and I'll just instance this texture here. And now I need to add the objects. Of course, you can also press H and add multiple objects like this. And now you can see as I move the objects around, the density varies. As the object comes closer, the density goes down, and this isn't really what I want. I want the density to be high around the object, not on the plane itself. So what I'll go and do, I'll swap these two colors so that the far color is black, which means the density is 0 at the edge of the distance, and it's white close to the object. And then the inside color is black, so directly below the teapot there won't be any grass at all. Now I wanted more grass in the scene, so I'll increase this value to 50 centimeters. And now you see I have a bigger grass fall off around each object. And the next thing I want to do is I want to control the length of the grass as well, so that it's short out here and gets progressively longer as we get closer to the objects. And the way you can do this, you can just copy this or instance this into the length map as well. And now you can see the grass grows longer as the object moves closer. And this is really great for setting up grass around the objects, or any kind of varied fur length, because you don't have to create the maps for this manually and update them every time you move an object in your scene. The effect will always just be related to wherever you place your object. And the last thing I want to do to this is I want to make the grass stand up more, actually make it less bent as it gets closer to the object. And to do that, I'll just copy this map here, and I'll assign this to the bend map. And this means that far away there will be no bend, and near there will be bend, so I need to swap this back. And also I'll change the fall off here to something smaller, like 25. And now you can see I have short bent grass far away, and as it gets closer to the object, the grass stands more up. Of course, now you can introduce a little bit of bend to the grass by changing the color here. I'll make this lighter gray, and I'll copy this to the inside color, and that way the grass won't be standing straight up, but it will still retain a small bend as we get closer. Now I'll show you how you can use the v-ray distance texture in an animated scene. I have a scene set up here with a field of blue grass and a red ball that rolls across it, and I want the grass to bend as the ball passes over it. So I'll start setting this up by selecting the v-ray fur object, and then I'll adjust the bend value to what I want to be the maximum bend the grass can have. And then I'll be controlling the amount of bend with a v-ray distance texture in the bend map slot. So I'll assign v-ray distance texture here, and I'll open the material editor and just instance this texture to control it. And then I'll go and add my sphere, my ball, and what you see now is you're getting the bend is the grass is standing up as the ball passes over, and this is not what we want, and that's because the far color here is means that it will be fully bent, and the near color means that it won't be bent at all, so it stands up. So what we need to do is we need to swap these two. And now you can see the grass is standing up, and as the ball passes over it bends. Now if I want the grass to be slightly bent before the ball passes over, I'll just go in here and I'll assign a lighter color, and now you'll see the grass has a slight bend until the ball passes over. Of course, if this was something like wet grass, the grass would likely be staying down after the ball has passed over. So how do we do this? Well, the trick here is actually to use a stand-in object for the ball. We're not going to use the ball at all to create our v-ray distance texture. So instead I'll go in here and I'll create a capsule. I'll set the radius to about the same as the ball, and add a few sides to it, and then I'll just position it where the ball is located. And I'll rotate it. This way. And then I'll just go in and I'll keyframe the height at the end of the animation. And then I'll display this as a box and make it unrenderable, like this. So now I have a capsule that actually follows the path of this ball. Now if I go into the material editor and remove the geosphere, and I'll add my capsule instead, you'll see that the grass actually stays down after the ball has passed. And if you have a more complex object path, you can always use a path deform on an object and link it to a path that follows the path of the original object. Or you can keyframe in objects for things like footsteps, etc. You can just put them down on the frame where they're needed. So I'll just render a frame from this. And as you can see, we have a slight problem here because of the grass in the middle standing up. And this is because the inside color is completely black, so we need to copy this color and paste this here as well, and that way the grass will stay bent. In this example, we'll be looking at how we can use the v-ray distance texture to control particle emission with p-flow. In this scene, I have a standard cat dinosaur rig walking across this plane, and I want him to kick up dust as he walks across this plane. So I've set up the material for this plane as a multi-sub-object material. This is the main material for the plane, and I've added a second sub-material with a v-ray distance texture. And I've added all the leg parts of the dinosaur rig, all the toes and the bones and the palm of the foot and everything, to this texture. And I've set the near color to white so that it will affect just the area right close to the foot within the radius of the 7.5 centimeters. I'll go into the particle view and I'll add a birth texture to the main event here, and I'll set the emit stop to the last frame of my animation. I'll just move this slightly out of the way. And I'll add my emitter object, my plane. And then I want emission by submaterial global, and since I have my v-ray distance texture in submaterial 2, I'll add that here. And I'll also bring down the whiteness threshold to about 45% so that I get more of the gray from a 45% point and up of the map, which would be about 3-4 centimeters out from the feet of the dinosaur. I'll also increase the amount of particles And now I'll initialize the particle emission. And as you can see, particles are emitted. I'll just go in and change the particle view color to something darker so we can see them. And you can see that the dinosaur kicks up dust as he walks. Now, as you can also tell, this is actually leading his foot by quite a bit. So I'll add some latency here, maybe 5 frames. And now the emission lags behind a little bit, which would indicate the way he actually the air pressure kicks up the dust. So this is a really good way to use the v-ray distance texture to control particle emission, and the v-ray distance texture is a really flexible and useful tool in v-ray 2.0 that can be used for a lot more than the examples I've shown you. In v-ray 2.0, the v-ray HDRI texture now has the ability to load OpenEXR or tiled OpenEXR textures. And to demonstrate the advantage of this, I have set up a simple scene of the Earth. The geometry is really simple, but the materials are using really high-res bitmaps, 2100 or 21,600 by 10,800 pixel bitmaps for things like diffuse, displacement, and also there's a blend material that uses shadow light fall off to blend between light material with a nighttime image of the Earth to get city lights. And then I have a cloud object just above it with displacement maps and an opacity map. Of course, loading all these textures makes, as you can see, the rendering requires 2.4 gigabytes just to render this simple sphere object. And on some systems this could be a big problem and would slow down rendering drastically. So a new feature in v-ray 2.0 is the ability to go here and I right click and I select v-ray bitmap to v-ray HDRI converter. What this does is it converts all the regular bitmaps. In my case I'm using ping textures, and it converts them to tiled EXRs, which have different resolutions in the same file, meaning that if you're far away, v-ray can load a lower resolution of the texture per bucket or render region, and it only needs to render what you can actually see. So I'll go ahead and click convert here. You can choose to store the data as 16-bit floating point numbers. You can select the compression method. I like to use zip, the tile size, and the linear mode. I prefer to leave this on auto. This determines if the image will be converted from sRGB to linear color space or not. For auto, it will automatically convert all regular formats like TIFF and PNG and JPEGs and leave EXR files and HDR files as they are. So I'll click OK here. Now this is going to take some time to convert because it's going to write all those different resolutions of the file to disk. So I'll pause the rendering or the recording. So now v-ray has completed converting all our bitmaps to OpenEXR tile textures. This took a few minutes, and fortunately this is something that you'll only have to do once for each scene or each material. And now let's go into the material editor and see what happened. I'll open the earth material. You'll see our old map is no longer in use, and there's a new v-ray HDRI map which has the new converted map where the old PNG file was located. There are a few options for tile textures. You can determine how big the cache size is. This is a common cache for all the tile v-ray HDRI tile textures. So this is the maximum amount of memory that it will be allowed to use. And then you have an option to clear this cache when the render finishes. And same with the cloud material. I now have a v-ray HDRI map in all my map slots. So let's render this again. And as you can see, memory requirements are now much lower, and also the rendering is cut in half actually compared to the previous render time of 18 seconds. v-ray 2.0 has a new texture called the v-ray multi-subtexture. And what you can use this texture for is to vary the colors or textures of within the same material on different objects based on either the material ID of the faces or the object ID of the object itself. So in this scene I have 3 horse objects, and I want them to have slightly different colors, but I want to retain all the other material parameters the same for these objects. So instead of creating 3 different materials where I have to go in and edit individual parameters 3 times every time I make a slight change, I'll use the v-ray multi-subtexture to create this effect. So first of all, I've set the gbuffer object ID to 1 for this object, to 2 for this object, and to 3 for this object. And I'll go into the material editor, and this is the horse material, and I'll assign a v-ray multi-subtexture to the diffuse channel. First of all, I'll just copy this as the base color, and I'll assign the v-ray multi-subtexture, and I'll paste my color in here. Now, since I have different object IDs on these 3 objects, I want to use object ID to differentiate the color. And I'll be using the first 3 slots here to vary the colors of these 3 objects. So I'll paste this color into these color swatches, and I'll make this one slightly darker, which would be the one on the left. I'll introduce some blue into that color, and I'll keep the one in the center the way it was, and introduce some yellow or make the one on the right orange, or an orange color. And as you can see, there's no viewport preview of this texture, unfortunately, but once you render, you'll see the effect very clearly. And now I'm free to, I'll save this to my history. I'm free to go into my main material here, and I can do things like I can play with the reflection glossiness. And all my materials, 3 different objects, are affected with the glossiness. And at the same time I'm retaining the color variation. So this is a really useful texture for adding variation to your objects in your scene while still maintaining very good material control. In this next sample, I'll show you how you can use the V-ray multi-sub texture to assign different bitmaps based on material ID or face material ID. In this scene I have a tree, an oak tree, and the leaves are a separate object, and I've divided the leaves into different material IDs. And the way I've set the material up is, this is a regular V-ray material, and in the diffuse map I have a V-ray multi-sub texture with get ID from face material ID, and then I have 4 different diffuse textures of oak leaves in first 4 slots, since I have 4 material IDs and my leaf polygons. And then I've done the same with the opacity map. I have different alpha channels corresponding to the other bitmaps, and this is fed into the opacity map slot down here. So when you render this, you'll see that the different material IDs of the leaves have different leaf textures, and you can of course add as many different leaves as you want, up to the maximum number in the texture, creating very varied canopies in your trees. And you'll still be able to go in and adjust all the material parameters of the leaves individually if you want to go in and add things like subsurface scattering or translucency, bump mapping, etc. One of the new render elements in V-ray 2.0 is the v-ray-dr bucket render element. And this is really useful for troubleshooting DR or distributed rendering problems. To demonstrate this, I've set up this scene and I'll render it using DR. And as you can see, I'm already seeing some problems with the irradiance map, and the problem is becoming even more pronounced when the final rendering is taking place. And as you can probably tell, I'm only rendering on 2 computers right now, so troubleshooting wouldn't really be that time consuming. But if you're on a big render farm with a long list of DR servers, then finding out which computer is not picking up textures or irradiance maps or light cache files could take a lot of time. So for V-ray 2.0 there's a new option to add a DR bucket render element, and this doesn't really have any parameters except for the text alignment. You can wrap the text if you have long names of your render servers. So let's render again with this render element enabled. And you'll now see that you have the computer name and a color code for each computer contributing to this render. And this will make it really that much faster to find out which computer is the problem. v-ray 2.0 has a new render element called v-ray-light-select, which lets you render the light contribution from individual lights as separate render elements. And in this scene I have just a regular plane and two v-ray lights, and I'll just set up the v-ray light select render element real quick. The only thing you need to do here is to add the lights you want to either include or exclude from that render pass to the render element. So I'll add the v-ray light 1 to this element, and I'll add another v-ray light select and add v-ray light 2 to this, and I'll also name this v-ray light select 2. I'll name this v-ray light select 1. So if we render this, this is my RGB color pass, and then I have a separate pass for light 1 and a separate pass for light 2. So if you composite these together, I'll just add a linear adjustment layer. Now you can just adjust the exposure of each light individually. Here I have a slightly more complex scene to show off v-ray light select. I have a bank of directional v-ray lights above each object, and I have a big v-ray light to the right. And in this scene I've added the render elements v-ray light select back row for this row lights. I have the front row where I've selected these v-ray lights, and I have the v-ray light select right, which is this big planar v-ray light. So when I render this, I get the back row lights as separate render element. I have the front row of lights as a separate render element, and I have the light source from the right as a separate render element. Also rendering the global illumination paths and the reflection in the objects. now I'll just open this in PD Player. I'll put my GI down here and I'll composite these additively, and I'll add a linear adjustment layer just to bring it into the correct color space. And now you can see we can turn off the back row of lights completely. We can turn off the front row of lights. We can turn off this, and then we can go in and we can start playing with the exposure. You can make the light from the right side much brighter. You can give it some color correction, making a warmer light from the right. The front row, you can color correct this, give this much cooler color. The same with the back. Maybe this one needs more red, I don't know. But you're much more free to experiment with your lighting in compositing when you can separate the lighting out this way without having to render the scene once for every light combination that you want to be able to adjust in post. Now I'll be showing you the new features in the planar V-ray lights. In this scene I have set up two planar V-ray lights above a white plane. And one of the first things you notice in v-ray 2.0 is when you enable hardware shading, you get a much nicer viewport representation than you did before, making lighting much easier in the viewport. So I'll go ahead and render this image, and right now both these lights render the way you'd expect a planar V-ray light from 1.5 to render. But one of the changes or new features in v-ray 2.0 is that there's now a parameter in the V-ray lights called directional. And what this does is, if I set it to 1, it makes the lines or the light from that light completely parallel, so it turns into a spotlight. And as you can see, unfortunately this doesn't show up in the viewport, but it does show up in rendering. So now, instead of this regular V-ray, planar V-ray light, you now have a spotlight. And you might notice that the light plane is now invisible, and this is actually physically correct because the camera is outside the angle where the light is visible. And if I lower the value to something like 0.5 to get something in between those two, you see the light now becomes visible again because the camera is now placed within the cone of light. If you need to have visible light sources in with a completely directional light source, the only way to do that currently is to make the light invisible and then put a stand-in geometry where that light source is. That's the only way to get it to show up from all angles currently. One of the benefits of having directional V-ray lights is that you can now use these lights as projectors to project images into your scene. And this is just a plain directional V-ray light, and I'll render this without any image. So you see you get the rectangular shape from the light. But then I'll go into the light and go down to use texture, and actually I'll grab this from the material editor. I have a circular texture here. I'll instance this in, and now when I re-render, you see I get a circular spotlight instead of this square shaped light entering my scene. And of course this can be used for a lot of different effects. You can add a different texture, like a more abstract yellow pattern here, and when I re-render this, this is projected into your scene. And this allows you to make some very creative lighting in your images. A very useful new tool in v-ray 2.0 is the v-ray specific light lister. This is basically the same as the light lister in 3ds Max, except this one is specific to v-ray lights. And this allows you to adjust all the lights, all the v-ray lights in your scene from this one interface. You can either choose to have a list of all the lights in the configuration rollout. You can work with the selected lights, where only lights that you select show up, or you can work with selection sets. So now I have defined a selection set for these 4 lights here. So if I choose to filter this by selection set, I can choose only those 4 lights. If I had more selection sets, for instance, if I put these 2 lights into a selection set and refreshed, I can now view either that selection set or that selection set. And these 2 lights are instanced, so just like in the 3ds Max light lister, they show up as a drop-down menu, and any changes you make will affect both lights. So it's very easy to just go in and adjust all the various parameters of the light. You can change the color, set the color temperature. You can define the units the light uses, if it casts shadows, how many subdivisions the light has, shadow bias. The lights can be turned invisible or visible, whether it should act as a skylight, and if it should affect the diffuse, specular and reflection channels. And then finally you have the caustic subdivision value for the lights here. And as you can probably notice, there are a few parameters, like the directional parameter, which isn't in the light lister. So in order to adjust that, you have to go into the modifier stack, but thankfully by clicking on this button, that light will open in the modifier stack, and you can just go in and adjust the parameters like textures and the directional parameter, which isn't available for the in the light lister itself. So I'll go back to all lights, and now you can just start playing around with the lighting of the scene, setting some colors for the various lights. It's much faster than having to select each individual light and going into the modifier stack, finding the correct parameter and adjusting it. So that's the v-ray light lister. v-ray 2.0 has a new light meter helper object that lets you measure the amount of light that hits a point in the scene in lux units. In this scene I have a very simple backdrop with a wall to the left and a box, and it's all lit by a V-ray sun off to the right. So let's go and measure the light that hits this scene. I'll go to Create, Helpers, V-ray light meter, and I'll just drag this out here. And the default size of this, or the segments of this, is 3 by 3. Sometimes this is not enough to get all the readings you want, so you can just go ahead and increase this to whatever amount of segments you need. The more segments you have, the longer it will take to calculate, because V-ray has to go in and calculate the lighting at each point here. So let's go ahead and calculate this now and see what it looks like. And when you calculate, you notice you get a couple of errors usually, and those can safely be ignored because they have no effect on the readings. I'll turn off the pseudo colors and the viewport text, and we'll cover those in just a sec. Orientation shows you the direction the light is coming from at each individual measured point. And down here under measured value, you can select if you want the total illuminance, the direct illuminance, which is the light that comes directly from the sun, or the indirect illuminance, which is the light that's bounced off the back wall here, or the daylight factor, which doesn't really have a direction. So I'll now turn on the viewport text, and this is the numerical readout of each measured light value at each point in lux units. Next, I'll turn on pseudo colors, and you'll notice now that this doesn't really correspond to this color range here, and that's because my range here is maximum 10,000, so anything above 10,000 will be clipped to white. And if you look at the viewport text here, I have values past 16,000. So let's go ahead and enable pseudo colors and increase the range to 18,000. And this brings the pseudo color display more into a visually pleasing range that's easier to read. Now, if you have huge variations in the light, if you have a very strongly lit area and other very dim areas, you might want to enable a logarithmic scale, because sometimes that will bring the whole range into the spectrum in a better way, in a logarithmic way, so it's easier to read it. I'll turn off the viewport text, and you can also use the various measured value parameters for the pseudo colors. So this is direct illuminance, this is the indirect illuminance. So you see this area gets more indirect light than this area, and this area gets no indirect light. While if you go for direct illuminance, all these areas here get, all these points here get a lot of direct light, while this one behind, obscured by the box, doesn't receive any. So let's just increase the resolution of the light meter to get an even higher resolution light meter. So I'll go set it to 20 by 20, and I'll calculate this, and you'll notice that this takes a bit longer than it did the previous time we used this. So there we go. When you have a really high res light meter, often the viewport text isn't very readable, but you can always zoom in and read the text. So I'll turn this off now and turn on the pseudo colors and the orientation. And you see we now have a much higher resolution measurement of the light that hits the scene. And this is the amount of daylight that hits the scene. So this area gets more daylight than this area. You see the values of the daylight contribution are really low compared to the direct light from the sun. If I go to direct illuminance, you'll see these are all, we had measurements in the close to 10,000 here, and daylight factor is barely above 60, 70, 80 here. Finally, if you need to export these measurements to use for various purposes, you can always save this to a comma separated values file, which gives you a CSV file that you can open in Excel or any other software that you need to bring these numbers into. In this section I'll be going through the interface changes that have happened in v-ray 2.0. There aren't any huge changes, but there are a few small nice additions that could really speed up your workflow.